So, we were looking at the reactions, the ionization and dissociation reactions that are happening in the arc, right? How it actually controls the temperature distribution of an arc. Suppose now we are going to even further, you want to calculate the actual heat is generated in the arc. Okay. So, again we need to know the electron density, the I in the arc, isn't it, and the potential created by these reactions. Or in a word, if you know that the electrical resistivity, okay, resistance of an arc, we can also calculate the heat, isn't it? Yeah, because R determines the resistance for the path of the energy carriers. So, obviously more the resistance, they will collide with each other, high energy, high collision rate. So, it is possible from the fundamental physics to calculate an electrical resistance of an arc. It is very simple. So, once you know that, we can calculate obviously the heat, and then we can balance it with conduction, convection and radiation. Okay, I am going to show you very simple derivation. Okay, how we can conduct the electrical conductivity of an arc. So, if you say the current in an arc, okay, so what is current? Is the transport of the charge carriers. So, what are the charge carriers we have in the arc? Electrons and ions. The electrons, they travel from cathode to anode, ions anode to cathode. Okay. So, the total electric current is nothing but, what is that? The electron current plus ion current, that is it, very simple, right. So, the total current, if you say that, that is the current of electron plus current of ion. And if you calculate the current of the electric current and ion current, and we can make use of that to calculate, so what is the resistance for this current, isn't it? So, if you know the length, area and the mass, okay, so we can calculate the conductivity or resistivity. So, first look at the electron current. So, electron current nothing but the amount of electrons travels from cathode to anode. This is nothing but the current density, the density of electrons, number density. The electron current is defined through unit area, right, amperes per square meter. Is nothing but current means it is traveling, isn't it? So, velocity. Okay. So, you have Ne of electrons, number of electrons, the number density, they carry a charge, isn't it? Electron charge E, the basic charge of an electron, times the velocity, that is what current is, right. So, this is the drift velocity. So, that is the average drift velocity. So, current is nothing but how much electrons you have times how fast they travel, isn't it? And during this process, each electron carry their charge of E. So, the charge is transported, okay, by the so and so number of electrons in a given velocity, right. It is clear. So, if you say the electron current Je is nothing but the elemental charge of an electron. How do you calculate the elemental charge of an electron? Very famous experiment. Yes? Yeah, oil experiment. What? Yeah, so Millikan's oil drop experiment. Okay, +2 physics, isn't it? So, this equation is also +2 equation. Okay. So, the elemental charge of an electron times the number of electrons you have, number density, times the velocity of the drift velocity of an electron would give you the current density, isn't it? So now how do we calculate each term? Ne we know, we can get E Millikan's oil drop experiment, okay, and then drift velocity. So drift velocity is including the collisions, okay, electrons collide and then they drift and then they don't go in a free path. So if it is free electron path, then it is the average thermal velocity. So in this case it is not the case, okay, resistance is created by the drift, by the collisions. So it is not the thermal velocity, it is the drift velocity, because that determines the electron travel. If you have high hindrance for the electron path, obviously you also reduce the drift velocity significantly, right, isn't it? If a mean free path is longer, the drift velocity will be higher, isn't it, because then you have less collisions, right. So we can get the drift velocity calculated, very simple equation. So drift velocity ue is nothing but the acceleration times the time between two collisions, okay. So acceleration is defined by meter by second square, isn't it, times second will give you velocity, isn't it. So when you have acceleration multiplied by times, you get drift velocity. And what is this time here? The time between two collisions, isn't it. So we are having meter per second, so we have acceleration times second, because this is a drift velocity. That means that after two collisions velocity changes, right. That velocity determined by how high is the acceleration, isn't it. And acceleration, how do you calculate acceleration, isn't it? What is F here? Yeah, it is electric field, okay. What is M here? A here? Acceleration of electrons, okay. So now from this equation, A is nothing but by ME, but ME is for 1, but you also have a charge associated with that, okay. So you multiply it by, sorry, here, right, because the electric field is governed by the charge of an electron as well, right. It's clear. So this is the force applied to accelerate a mass ME, and if the force is E times E, the acceleration is given by the force by mass, isn't it? Simple, right. So you substitute acceleration in this equation, what will happen here? Now we have an equation for drift velocity, which is nothing but coming from this equation, isn't it? The force, the electric field which determines the drift, okay, the acceleration of the electrons, how much field you apply between the cathode and anode, isn't it? Okay, that will determine the acceleration, okay. How fast the electrons travel from cathode and anode determined by the field, the potential difference you apply, okay. So then Te is the time between collision, that will determine your drift velocity. Again, how do you calculate the time between two collisions? It is very simple, okay. The average mean path over thermal velocity, okay. So again, so this is meter by meter second, and this becomes second. It's clear? So, we can substitute TA also from these equations. Why do you substitute? Because it's very difficult to calculate the collision between time between two collisions. But we know what will be mean free path at a given temperature of an electron. So, what will be the average thermal velocity that can be calculated, okay, for an electron. So, we substitute that, we get the drift velocity as a function of the applied electric field, and then mean free path, mass, thermal velocity. Okay. So, again the Boltzmann, from the Maxwell-Boltzmann equation, the average thermal velocity is given by square root of 8 kT by me pi. Okay, so any particles. Okay, so we know the equation for the average thermal velocity. So, now we can apply to the average drift velocity. So, average drift velocity is nothing but here. Okay. So, this is coming from acceleration, isn't it? And then LE is mean free path, and then what is this? Thermal velocity. Okay. So, if you use that, apply that, and then UE becomes, so VE is nothing but square root of 8 kT by, isn't it, here. So, ME is here, ME times by ME pi, and here we have LE, isn't it? What will happen here now? UE, so the bar on top of the velocity is extremely important. Okay. This will becomes by pi, isn't it? Because ME goes inside, ME square, ME in denominator cancels out, right? It's clear. And we now have the equation for drift velocity, and now the electron density, current density is nothing but the first equation, E, number density, and then drift velocity. So, if you replace UE with this term, then we have the electron current density, isn't it? It's nothing but, so E over here and E here becomes E square, and then the field you apply, number density, mean free path by square root of 8 ME, the mass of the electron, Boltzmann, temperature, and pi. Yes, it's clear. So, in these equations, the electron density is determined by two important variables here. What are the variables here? Which are all the constant, and what are the variables here? The electric field, temperature. Okay, the other all, for example, this is constant. Okay, this is determined number density. So, now the electron density, current density is determined by the field and the temperatures. So, obviously, if temperature is higher, so you create more resistance, because the collision, number of collision incidents increases, the drift velocity decreases, isn't it? You apply higher electric field, what will happen then? Okay, the current can flow much faster, the drift velocity increases. That is the relationship.